Good morning, students. We are going to discuss wastewater treatment. Wastewater treatment, we have two different kind of wastewater. According to the wastewater generated from the domestic, institutional, clinical environment, or whatever the wastewater created or generated from the industrial, we can say domestic sewage and industrial sewage. According to the parameters, we can able to understand either we can go for the wastewater treatment or some other method for the removal of the impurities or pollutants. So the domestic sewage water contain some of the parameters may be used to treat these methods. Liquid waste that contains many different substances. So it depends on that one. We can able to measure amount of organic materials in sewage is measured by biological oxygen demand. Strength of sewage is measured by the total suspended solids. Plant nutrition is another impurity that is containing nitrogen and phosphorus. Domestic sewage contains biological oxygen demand 200 mg per liter, total suspended solids 240 mg per liter, nitrogen 35 mg per liter and phosphorus 10 mg per liter. So industrial waste contains more biological oxygen demand and total suspended solids, but depends on the source. Either it is coming from the textile industry or dye industries. According to that one, it may contain more. So whatever the domestic sewage may have the limitation in the particular impurities. So these kind of impurities we can able to treat in simple methods. So what are the purpose of wastewater treatment? The basic purpose of sewage treatment is to destroy pathogenic microorganisms and to remove most suspended and dissolved biodegradable organic materials. It is also necessary to recover water for recycling purpose. What are the steps involved in treatment? Preliminary treatment, or we can call it the pre-treatment, primary treatment, secondary treatment, tertiary treatment and sludge digestion. First one, pre-treatment or whatever the preliminary treatment. First, we have this larger size tank, so which we are passing the wastewater into the screening. So, what are the bar screens retain coating debris, bulky objects that could clog pipes or damage mechanical equipment in the rest of the water treatment plant. So, just we have to filter all those kind of large size particles in the screening. Then grit removal. A grit chamber where small particles like sand, stones are allowed to settle. So we have to allow the filtered water to stand some more time to settle down the larger size particles. Then primary treatment. The suspended organic solids are removed by sedimentation in primary clarifier. What are the larger size tank? Allow the suspended particle can easily skim off by using the skimmer. Then sludge that settle down is removed and oil, grease are skimmed off from the top. Then coagulants are added to remove the tiny particles. Normally the coagulant we are using to remove the tiny particles, form the better enough size larger particles to settle down in the bottom. So about 60% of suspended solids and 30% of organic materials are almost removed in the primary treatment itself. Then secondary treatment. Fine suspended particles and dissolved organic matters are removed. So here we have this almost most of the suspended and then dissolved organic matter we can able to remove. But we are going for the different kind of biological treatment. So that is using the microorganisms. So bacteria and protozoa consume the organic pollutant as a food and convert them into carbon dioxide and water and energy. So this process requires actually oxygen. That is the secondary treatment methods. So we have this common two different methods we are using. The first one, trickling filter and activated sludge. So both almost remove 85% of biological oxygen demand and total suspended solids. Trickling filters. This is the simplest method. So the microbes remain attached to the surface while the wastewater flows over them. It is a fixed growth system. So what are the microbes which may be absorb the pollutant from the wastewater? Okay, so as the primary effluent trickles downward through the bed of the stones, a biological sleeve of microbes develops on the wastewater over these fixed biological growths and provides the needed contact between the microbes and the organics. So due to that one, it's consume all the pollutants, most of the organic pollutants which is present in the polluted water or wastewater consumed by the microbes and get digest and then going for the decomposition of the waste. So for this one option we needed to stabilize the particular microbes. So this is the trickling filter. Just we fix in the uh, top layer the microbes, then it's completely rotating drums. So whatever the use the supply the oxygen for both the side using the air. So when it's going for the microbes absorbing or whatever the water, whenever it's passing through the microbes, it consume the pollutants as a food and then digest. Then it may be release some energy, whatever the residues. So that residue may be collected in the clarifier as a sludge. Then whatever the water, it may be removed from the top layer, which we can consider as a treated water. So we have to go for the checking the parameters, BOD and total suspended solids. According to the parameters, if it is allowed level, we can let it go for the pressure treatment. Other than, again we have to take it into the uh, trickling filter once again, then use the microbes to treat. Then we are getting the additional sludge, then treated water will get it. The next secondary method is activated sludge. Whatever the activated sludge is, small quantity of microbes just we are thoroughly mixed in the water, that is in the particular wastewater tank. So due to the activated one, it's efficiently uh, absorb all the pollutant in the wastewater. Then it's going for the digestion. Almost more than 6 hours it's taking to complete digestion. Then that activated sludge completely settle down in the clarifier due to the gravity. So whatever the coagulant which we are using, here silica, so whatever this one, it may be going for the uh, oxidize all the impurities as a carbonous or nitrogen compounds into the uh, carbon dioxide or water as well as the some energy. It may be the as a fuels also. So that microbes really decompose almost all the organic compounds present in the wastewater and then going for the uh, pressure treatment. So what are the pressure treatment? This is almost used to mainly recover water for the recycling purpose. Okay, so we are having the different kind of filters. So the top layer may be having the fine sand. So then we have this different kind of gravels. Whatever the gravels, large size gravels, then fine gravels, then you have this coarse sand and then fine sand. Then you go for the uh, pausing the secondary treatment method, treated water. We pass into the tank. Then slowly it may be going through the different kind of beds. Then finally almost all the impurity may be filtered in the pressure treatment methods. Finally, whatever we have to check the bacterial uh, test. So according to the content of bacteria or whatever the uh, method we can able to choose the disinfection. So either going for the ozonization or whatever, you can go for the bleaching powder, that is the chlorination. So either by the bleaching powder, that is the municipality select the bleaching powder, that is the best method, the cheap best. According to the quantity of water, they may be calculate the bleaching powder. Then it may be killing the microorganism which is present in the wastewater. After checking the pathological impurities as well as microbes or pollutant level, then the water may be let it into the discharge into the uh, other water bodies. So what are the residue we received from the secondary treatment method? So that sludge we have to digest, and then we can able to collect it into the as a fertilizer as well as whatever the gas produced during that one. If it is methane, we can collect it as a fuel. So while during the digestion, it may be reduce the volume, and then going for the increasing enriched fertilizers, whatever the nitrogen and phosphorus containing fertilizer, what are the gases may be produced, carbon dioxide and methane. So whatever the methane may be collected according to that one, you can use it as a fuel. So these are the general graphical uh, representation of the wastewater treatment. First, we pass the wastewater in the from the inlet chamber. Then it may be going for the pre-treatment, that is screening. In this stage, we can remove almost bulky objects from the screening. Then grid removal or whatever the grid separation using the larger using the time allow for the 24 hours. At least it's settled down almost large size particles in the bottom. Then primary treatment. So here we have this coagulant we are adding for the treatment methods. Then the secondary trickling filter and activator stage we are using to remove almost most of the uh, organic material pollutants. Then we go for the tertiary treatment. Here we can able to go for the removal of pathogenic impurities. Finally, it may be discharged into the any water body. We can able to recycle the water, or we can reuse for the gardening or some other purpose according to the removal of the impurities. Okay, thank you.